All right, so today we're going to be talking about special right triangles. All right, so these should be in your notes. So when we're talking about special right triangles, there are two types of special right triangles. They are the 45-45, 90, and the 30, 60, 90. Let me just, not what I meant to do. All right, 45, 45. Let me just retry that. 90, and the 30, 60, 90. So the reason why they're called the 45, 45, 90 and the 30, 60, 90 is because the special right triangles is referring to the angle measures. Right? So that means on a 45, 45, 90 triangle, as you can see down here at the bottom, we have a 45, and a 90-degree angle. On the 30, 60, 90 side, we have a 30, a 60, and a 90. So again, special right angles, just referring to the angles. The special right triangles is just referring to the angle measure. All right. So today we're just going to look at the 45, 45, 90. We'll take on the 30, 60, 90 later. All right. So when it comes to the 45, 45, 90, there's a very simple way that we can go about doing this is if we set up a chart. So just like this, just kind of make that tic-tac-toe board. We have a 45, 45, 90. So we have our angles here. We have the rule here, and then we have its actual value. So the reason why we're covering special right triangles is because special right triangles gives us how to find the sides of each triangle. So if you remember with right triangles, you can use Pythagorean's theorem, Pythagoras theorem, which is that a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Well, when you have a 45, 45, 90 and a 30, 60, 90, we have very specific rules that happen with the legs and the hypotenuse. So the most important for the 45, 45 is, since they're both isosceles triangles, that means that the legs have the same value. So I typically use the lowercase cos of L, which just looks kind of like that little squiggle thing, whatever you want to call it. So when we have that those two, we get that the hypotenuse is L square roots of 2. So when we plugged it in, we have L squared plus L squared is equal to C squared. Well, we have 2 L squared being C squared. So when we take the square root, the L squared goes out, leaving this 2 squared alone. So we have that the hypotenuse is equal to 2 times the square root of 2. I'm sorry, the hypotenuse is equal to the leg times the square root of 2. So again, special right is just saying, hey, when you have this triangle, we can use these specific rules. And let me go ahead and clear the board. We don't need that anymore. So all we were saying was, hey, we have this L, and this is L times the square root of 2. What are you doing? Come on, don't do this. All right. Quit that. I don't want you to. So L square root 2. So that means on the rules, that's all we'll put. L square root 2. All right. So that means whatever values we have, we can just plug it in. So for instance, if I said, hey, this side is 2. But we know at across from the 45, across from the 45, across from the 90. So we know across from that 45 we have the 2, which meant that the L leg would be 2 because L is equal to 2. And then all we had to do is substitute the value of L into the 90-degree one. It's giving us 2 times the square root of 2. All right. So we can use this rule to find all of the sides if only given one side. So for instance, if on this 45 we have 5 square roots of 2, well, then it's pretty simple solving for the square root, solving for the legs. Because you have that 45, 45, 90, L, L, L square root 2. And so while we don't know what the L's are equal, we know that the 90 degrees directly across from that 90 degree is 5 square root 2. So if L times the square root of 2 is equal to 5 square root of 2, that means, hey, we just divide by that square root of 2 to get rid of it. Those cancel, leaving us that L is equal to 5, which means that both legs would be 5. Right? So not every time we'll have the square root 2 in front of the L. Most of the time you'll see that though. Occasionally you might have, for instance, for our last triangle, let's go with, let's just go with 16. Alright, so again, we just set it up. We have 45, 45, 90, L, L, L square root 2. So we know that each of these is equal to whatever's over here. So we have L square root 2 is being equal to 16. So it's not quite as simple as the previous one where L was just what was in front of the square root 2. Now we have L square roots of 2 is equal to 16. So now we actually have to solve for L. So when we divide by that square root 2, while those cancel, it doesn't over here. So we have L is equal to 16 divided by the square root of 2. And remember, we cannot have a radical on the denominator. We have to rationalize the denominator, which means in order to rationalize, all you're doing is multiplying by the radical. You're multiplying both the numerator and the denominator by that radical on the bottom. So when you do that, you get, hey, L is equal to 16 times the square root of 2 on top, and the square root of 2 square root is just 2, which can simplify because 2 goes into 16 8 times. So that's 8 square root 2. So that means L is 8 times the square root of 2. 8 times the square root of 2. All right.